Okay, and to finish off our sequence of videos on similarity, I just want to look at some problems involving similarity. So we're just going to look at 3 examples here. So example 1, the shadow of a tree is 4 meters long, and at the same time, the shadow of a nearby 1 meter fence post is 25 centimeters. Assuming both the tree and the, and the fence post are perpendicular to the horizontal ground, what is the height of the tree? Okay, so we've got horizontal ground, we've got tree, and fence post. Okay, and we assume that the tree is perpendicular to ground and the fence post is perpendicular to the ground, so they're at right angles to the ground. Okay, the fact that they're nearby, and it's all about the shadow, is all about telling us that the rays of the sun are coming at the same angle. Okay, so if the tree, let's say for example, produces a shadow that's this long, okay, and the fence post, sorry, it's not very accurate, let's try that again. The fence post produces a shadow that's that long. These are parallel lines, okay, because if the two things are quite near each other on the earth, the rays of the sun are coming in the same direction, okay, and so what that means is that that angle up there will be the same as that angle there, and that angle down there will be the same as that angle there, and we have similar triangles due to angle, angle, angle in this particular problem, okay. So we know the shadow of the tree is 4 meters, we know that the fence post is 1 meter, and we know that its shadow is 25 centimeters. So we want to be consistent with units, so that's 0.25 meters, okay? Or else you make it 400, 125. As long as it's all in the same units, that's okay. We want to find the height of the tree, okay? So we can either work out the scale factor using the 4 meters and the 0.25 meters. So the scale factor is going to be 16. And so therefore the height is going to be 1 times 16, so it'll be 16 meters, or we set up the ratio h divided by 1 is the same as 4 divided by 0.25. It's essentially the same maths that happens in both methods, okay, it's just a different way of setting up at the beginning. H divided by 1 is just h, 4 divided by 0.25, as I said, is 16. Okay, so the height of the tree is 16 meters. If we'd been working in, if we changed everything to 400 and 125, so we worked in centimetres, we obviously would have got a height of our tree in centimetres, 1600 centimetres, which is not an ideal way of measuring the height of a tree. Okay, example 2. The diagram represents a river, which is shaded in the diagram, so this is the river, okay, with a tree on the bank at point A, so there's a tree over here at A. A man stands directly opposite A on the opposite bank at point B. Okay, so the man is at B. If he's directly opposite, that's what's telling us about the right angle. Okay, so going directly across something is going to be a perpendicular distance. He then walks from B along the bank towards C. Okay, where he places a peg. So he puts a peg in the ground here at C, and then he walks a further 50 metres to point D. Okay, so this was 100 metres, and this is 50 metres. He then turns 90 degrees and walks 65 metres to point E, where he finds that E and C and A are all in a perfectly straight line. Okay. Alright, so in terms of thinking about triangles here, we've clearly got a right angle in both of the triangles. We've got vertically opposite angles that are going to be equal to each other, and therefore if 2 angles are equal, the third angle by subtracting them from 180 will also be equal. Okay, so we have similar triangles due to angle, angle, angle. Okay, again, in order to use them, let's reorient them. So let's stick with our larger triangle in its current orientation, and let's turn around the smaller one as well. Okay, so if I've got my pink vertically opposite angle here and my third blue angle up here, making sure all the information's in the right place. So in the bigger triangle, between pink and the right angle is 100. We don't know any other lengths. In the smaller triangle, between pink and the right angle is 50, and that is 65. We are trying to find the width of the river. So that's what we want to find from A to B. Okay, so that is this distance in this triangle. So again, we can use scale factor because that's a nice scale factor here. We can see that it's double. Okay, so we can see that the scale factor is 100 minus 50, which is 2. And so therefore, we know that x is going to be 65 times 2, so 130 metres. Alternatively, we could set up the ratio. X divided by 65 has to be the same as 100 divided by 50, and so x is 100 divided by 50 times 65, which is 2 times 65. Oops. So 130. As I said, it's the same maths. You end up doing the same maths. It's just about you either separately work out the scale factor, then use the scale factor, or you essentially do that all at once in the ratio statement. Okay, third example here, an inverted cone with a height of 10 centimetres and a diameter 8 centimetres is filled with water to a height of 6 centimetres. Find the surface area of the water. Give your answer to correct two decimal places. Okay, so surface area of the water is just area of a circle, and area of a circle is pi r squared. Okay, so we're going to want to know what the radius of this is. That's what we need. Now we know that the radius of the larger triangle is 4. Sorry, larger cone is 4. And we also know the two heights. So actually we've got this sort of a situation. And again, due to the fact that these lines are parallel, those angles will be the same. That's a shared angle down the bottom there, and they've both got right angles. So we have similar triangles due to angle, angle, angle. Okay, and then if we think about, If we think about those two separate triangles, again, drawing them out separately, we've got our larger triangle from the larger cone, where that is 4, and that total height is 10. And then we've got our smaller triangle to do with the water, where that is 6, and that is what we're trying to find, the radius. Okay, so we can work out the scale factor using the 10 and the 6, or we can just say that r over 4 is the same as 6 over 10, and so therefore r is 6 over 10 times 4. 6 divided by 10 times 4 is 12 on 5, or 2.4. Okay, so the radius of the water is 2.4, and so therefore the surface area is going to be pi times 2.4 squared, which will be, and we want two decimal places, pi times 2.4 squared is two decimal places, interesting one to two decimal places, 18.09, but we need to round up, so 18.10 correct to two decimal places. So you do need that 0 correct to two decimal places, because it's not exactly 18.1, it rounds to 18.10. And it's a surface area, so it's an area, so it's centimetres squared. Okay, so the practice today is from exercise 17E.